Hello and welcome. My name is Sanjay Soni. Here is a micro-learning readiness video about Azure SQL Data Warehouse. Thank you for taking the time to join us. Now, let's get started. Hi, Ron. How are you doing today?
Doing well, Sanjay. Good to be here.
Great to have you back here. Can you please tell us more about yourself? What do you do at Microsoft?
Yeah, I'm a senior program manager at Microsoft in the Azure SQL Data Warehouse group.
All right, let's get started. So can you please walk us through some scenarios where workload management makes life better for Azure SQL Data Warehouse customers?
Absolutely. Let's cover the first kind of scenario here around where importance can come into play. So with SQL Server on our control node, kind of level setting here on the architecture of the service, we have a control node. Within that control node, we have software scheduler. So if you think about scheduling requests, in this scenario here, I've got some requests that are coming in. They're in a running state here, denoted as blue requests. Then I have some queued requests here, 9, 10, 11, 12, off to the right. Those are in a queued state. And our poor, lowly CEO here has come in, and he's the 12th request. So it's the end of, imagine a scenario here, it's the end of the fiscal year. He wants to get his sales report to finish, okay, but he's last in the queue. So what happens in this case, let's say request number 3 finishes. Today with our scheduler, number 9 was the first one in. He's the first one we pick up. Now our CEO has gone from smiley face to not so smiley. All right? Number 5 finishes up, and then number 10 comes in, and now our CEO is mad, right? His queries sat there queued for this whole time, all right, and his reports aren't running, and this is where he gets very angry and starts the turn in your badge mode. This isn't a great experience. I want my reports to run faster. So those sorts of scenarios that nobody really wants to be in. Mm-hmm. So now with importance, what happens in the same sort of setup, now I've got the scheduler with importance. We're back to our same scenario here set up. Requests 1 through 8, they're in a running state. 9 through 12 are sitting there queued. Our CEO, again, shows up last. He's the 12th request, so there's 3 other ones that are ahead of him. But now we've actually labeled his request with high importance through classification in our workload importance setup. So in this case now, when request 3 finishes up, the CEO's query then gets scheduled because he's the most important, and he's now in a happy state. His query is up and running, and his report will refresh on time.
I see. So instead of those other last three ones, you basically moved CEO's request prior to this.
Yep.
Okay. So what happens if high importance requests fill the queue? Then what do you do?
Great question, Sanjay. So in a scenario where we have all high requests, so if we went back to that previous example, let's say 9, 10, 11, and 12 are all high, we actually go back to the FIFO type model where the first one that comes in is the first one that we would serve.
So first in, first out.
First in, first out. Great question. All right, well, let's take a look at a demo here and see how this looks in live action. So this is basically the new classification syntax that we have set up. So you see here the create workload classifier. I'm going to actually create the first classifier here with the data analyst. I'm going to put him into the extra large resource class, and then I'm going to assign him normal importance. I'm also going to assign the CEO here into the extra large resource class. So his login is the CEO, very original. And he'll also be put into the normal importance group. Okay, so now I'm going to go ahead and kick off 3 queries at the same time, including the CEO. All right, so when I come back now and monitor these queries, I can see the CEO is in a suspended state. The data analyst is submitted there. He is also submitted and in a suspended state. All of our importance is normal, and the data analyst is running as well. So he's already got up and started. We're basically just picking through these in the order that they were received. If I look at this from, again, querying our DMVs, I can see here with this one that I've sorted by submit time. The submit time is basically equal to the start time. So again, that goes back to that first in, first out type model, right? All the importance is the same. All the resource classes are the same. These guys will be executing in the same order. If I ran the same query again, but now I ordered by start time, I would see again, data analyst, data analyst, data analyst, and the CEO ran last. All right, so first in, first out model, no importance is applied. No differentiating importance was applied. Now we come and recreate the classifier for the CEO. So the CEO is there, his importance is now high.
High importance.
Right?
Okay.
The data analysts are still low, okay? Or excuse me, medium. Excuse me, normal importance. So let's go ahead and run these guys again. All right. All 4 queries are up and running. If we take a look at the monitoring again, we see, again, this is sorted by submit time. The CEO has already been put into a running state.
Fantastic.
He's got high importance, he's up and going, and his start time is done. If we take a look again, same model, we sort this by submit time. Again, as we would expect, I click those in sequence order, so the data analyst queries go first, were submitted first, and the CEO was submitted last. But when I order by start time, now we see that the CEO was able to get in and run before the other 2 data analyst queries. So I just missed the start time there of getting the CEO to actually run first.
That was great. So what about classic scenario where read activity and write activity conflict? Data load while query is happening. Can importance help there as well?
Absolutely. Let's take a look at that scenario actually. So importance can help influence how locks are being accessed. So if we take a look at this scenario, again, we're on the control node, we have our scheduler, and locking here now without importance is what we want to take a look at. So in this case, I've got 3 queries that are in a running state. Queries 2 and 3 are actually holding on to a lock that query number 4 needs. So think of a classic scenario where I've got a very actively used fact table and I do a daily load. I want to actually load that data up and do a new partition. And then as the last step of my ETL process, I do a partition switch and I switch that into the target table. Well, now with queries 2 and 3 running and that partition switch wanting to happen, the query 4 is just going to sit there and wait and wait and wait. All right, and what happens now with SQL DW today without importance, when query 2 finishes, query 5 can jump right over number 4 and go into a running state. So if number 5 also wants to go after that highly used sales fact table, query 4 will sit and will have to wait. Even if query number 1 finishes, query number 4 has to wait because the locks are held by requests 3 and 5. Now you can imagine a scenario where queries 6, 7, 8, 9, 10, 11, 12 all wanted access to that same fact table. Query 4 has to sit there and wait for all of those things to drain until there's a quiet point on the system, and then it can go ahead and execute that partition switch. So if you put a lot of value on having data loaded and data refreshing, this can be a bit of a troublesome scenario for you today. So let's take a look at what this looks like with importance now.
All right.
So similar setup. I've got queries 2 and 3 that are in a running state. Query 4 wants to come in with the partition switch. But now I've actually stamped importance on top of these requests. So you can see here, query number 4 has high importance tagged on it, while the other ones have normal importance. So in this case, now when query 2 finishes, query 5, which could run, is actually blocked. Mm-hmm. All right? Then when query 3 finishes, now 4 can get into a scheduled running state, and the partition switch can complete right away.
That was great. Can we please see a live demo?
Absolutely, Sanjay. All right, let's take a look here at the screen. I'm going to actually set up again my classifiers. So now this time I'm going to create a classifier around the ELT role. So this is what's doing my data load, what can do my renaming of objects, my partition switches, my CTAS operations. And then we have the data analyst guy, the guy that's coming in and running queries nonstop. So the first classifier was around that writer role, Sanjay, and the second classifier is around that reader role. So let's build just a temporary object here. Think of like I have a star schema or even a snowflake schema that I want to denormalize for some reporting. All right, so here I can do a CTAS operation. You'll notice here I'm actually creating a single partition table.
So CTAS is create table as select?
Exactly. Right. Yes, exactly. So just a small table here for the demo purposes. Now let's say I've got that data loaded. The next day I've got new data that's come in and I need to actually get that table refreshed. So I'll do another CTAS operation. This time I'll pull in 150 records. If we take a look at the row counts, when that's complete, so my existing table has 100 records, my new table has 150 records. This is think of this as like a full load scenario, so I just want to make the 150 records go into the target table, the customer demographics table. Okay, so let's kick off some user queries. So again, these are all running under the data analyst connection. And what I've done here is I've used this Go 1000 syntax. So what this is basically going to do is just run this in a loop 1,000 times. Okay. So I'm trying to simulate now some read activity that's going to be constantly pounding this table. So here's my customer demographics table. That's the one I want to get the data refreshed into. If I take a look here, all right, I've got all my queries up and running. They're submitting queries. I am a little bit overloaded now, so you can see I have a query that's in a suspended state, which is fine. The system's busy. It's serving up queries. So what I could do, if I wanted to do like an old school example, in this case, I could do the old rename of the object. So I could name existing to the old, and then I could do the daily load into the existing table. That's going to require me to get 2 locks. Don't necessarily have to do that. So you saw before I created the tables with a single partition in them. So now I can use this new syntax called with truncate target on. So this will do a partition switch of the daily load table into the target dim customer demographics with truncate target on. So this is one operation, switches all the data into the new target. So when I kick this off, I'm hoping this would complete quickly. But unfortunately, I still have that read activity going on. So now I see this guy's in a suspended state. If I look a little bit deeper here, I can see this is sorted by submit time. So now this submit time guy, the ETL role, is trying to get that partition switch done. This guy has already started, so it's jumped over it. Notice how the start time is greater than the submit time here. So it came in a second after that. Okay, so these data analyst queries will continue to jump over this partition switch statement, and you see here it just keeps running and running and running.
I see.
All right, so now if I stop it, and let's adjust his importance now. So let's say ETL role is high priority, high importance. All right, then we try to run this guy again. Okay, again, the queries are still running. They're still live on the system. We jump over here and take a look. Okay, notice how nothing else is starting after this guy. So he's in the queue. He's waiting for things to drain. All right, and guess what? It's already finished. Okay, so there, that query jumped in and finished, whereas before it was hung waiting forever. And I've got 150 records in my target table.
That was great. So are there any other scenarios where workload importance comes in handy?
Absolutely. There's one other scenario here I'd love to show you, Sanjay. So this is a scenario where I have what I call non-uniform requests. And we go back to our kind of favorite scheduler diagram here. And we see we've got 1, 2, 3, 4 blue running requests here. Now you see 5, well, that's a double wide request, I call that. So it needs a bigger memory grant. It needs more resources for it to actually get up and run. And today with the scheduler in Azure SQL Data Warehouse, it is optimized for throughput. So as query resources free up, we try to find things that are waiting, and we put them into a running state. Okay, so while that may be good for some scenarios, it may not be good for all. So in this case here, when query 2 finishes up, number 6 query will jump right over number 5 and put into a running state. Okay, query number 3 finishes up, number 8 can fit in that slot, it jumps right over 5 and 7, and it goes into a running state. So now imagine other things queuing up behind 9, 10, 11, 12 that are all of this kind of small single memory grant request nature. They'll just continue to jump over 5 and 7, and they'll sit there forever. Okay? So not necessarily great if I have to load up like a big fact table and I require a larger memory grant for that, but I also still want to keep running my smaller dimension tables at the same time.
The replicated dimension.
Yep. I can't assume that I have uniform requests all the time, that everything fits into the same memory grant. So I want to create tables I want to use requests that require larger memory to get good CCI compression, build good compressed fact tables. So now let's take a look at that with importance. So again, back to our scenario here, some requests that are running in blue. I've got queued requests, but now these requests are stamped with importance. So query number 5 actually is stamped and tagged with high importance. So in this case, when query 3 finishes, because 5 is of high importance, it will block number 6 and not allow it to run.
I see.
Okay, we wait for number 4 to finish up, and then query 5 slides right in there and gets into a running state. Number 2 finishes, while both 6 and 8 and 9 and 10, which are of normal importance, will be blocked because 7 is high importance and it needs more resources before it can get scheduled. So when 1 finishes up, now the scheduler kicks in, 7 jumps right over number 6 and can get into a running state. So here in this scenario, I've overlaid importance on top of non-uniform requests to influence the order of execution. I've got high important requests requiring large memory grants. Importance will allow you to make sure they get scheduled in the correct order and allow you to hit your SLAs.
Great. Can we see a live demo?
Absolutely. Love to show you another one here, Sanjay. So I'll go ahead and set up the classifiers again. So we've got the data analyst query. He's going to be in the static resource class 60 group. It's the data analyst, and we will set his importance to normal. Now to create this kind of non-uniform request scenario, I'll create the CEO back with normal importance, but I'm going to give him an extra large resource class grant. So he's going to be the double wide in that diagram that we were looking at before. His request is basically double the size of that static RC60.
I see, more resources needed.
Yep, we want to give more resources to the CEO. We want to make sure his queries run the fastest, but right now we have him set with normal importance. So the playing field is level for both of these guys. So let's go ahead and kick off some queries. Again, I've got the Go 1000 syntax here, so these guys are going to run in a loop. And then I've got the CEO, I'll kick him off here at the end. Now remember, he's running with extra large resource class. These guys are all running the same query just for simplicity's sake, but they have different resource classes and they're going to ask more resources from the system. Okay, so let's take a look at the DMVs here and see how the live system's running. So now I can see I've got my CEO query. He's in a suspended state, of course, not happy about that. His importance is normal, and he's got the extra large resource grant. We can see here, because I'm ordered by submit time, that the data analyst queries are jumping right over him. So his submit time is back at 28 seconds, and now we're a couple minutes later here, and the CEO queries are getting submitted, and they're also getting up into a start time and running state. These data analyst queries, because their request needs are smaller than the extra large resource class for the CEO, they will continue to be scheduled and into a running state while this CEO will sit there forever. So let's go ahead and stop this guy, stop the CEO, and let's adjust his importance. So here I've got the classifier. This is for the CEO. He's going to stay with his large resource grant, but now we're going to give him high importance. Okay, that runs in just a second. Let's go back and let him try again. So while that's going, let's take a look at the monitor. DMV's here. And now we can see, well, he's already up and running. Okay? So his query's been scheduled. He's in a running state. These other ones have been submitted after him, and even the ones before him, they're in a suspended state because the extra large resource class requires such a large grant. And we go back and we see his query's already finished. So CEO is happy.
That was great. Thank you so much for all this great information today.
You bet, Sanjay. My pleasure.
And glad to have you here with us.
Absolutely.
Thank you for watching this video. Learn more about this and other topics at azure.com/SQL DW.